the example I was discussing is, let's say we are given this side BC to be 5, for instance, okay, and we are given side AC to be 2, okay, then we said find the value for side AB. All that we do is we substitute A is 5, right? 5 square, okay, and then B is AC, which is 2, okay, plus 2 square using Pythagoras theorem, which will be equal to H square, which is the side we don't know the value of. And what this means is H will be equal to what? Will be equal to the square root, okay, of 5 square plus 2 square. That's 25 plus 4. All right. And then you have the value for this side, the hypotenuse side, which is AB. So that's how we use the Pythagoras theorem to find the sides, value of sides of a triangle. And remember, this triangle is a right-angled triangle, which if a side of it is angle 90. And then I go to the three trigonometry ratios and reciprocal. We are familiar with that. Sine A equals to opposite over hypotenuse and all of that. We discussed it last class. So I'll go to the next slide. Trigonometric functions of complementary angles. And the acute angle AB in this example now of the right triangle ABC are complementary. What does it mean? If you look at A plus B will give you 90 degrees. And this is it. I'll show you what A is. That is this angle plus this angle will give you 90 degrees. No, I'm not drawing this 90 degree. If you sum it up, I need to clean this. If you sum it up, clear notation, it's going to clear everything, but it's fine. We give you 90 degrees. So it's angle A. I'll do it again. Angle A plus angle B. We give you 90 degrees. Okay, and we can actually see that from the example we have here. Find the value of sine A, cos B, and cot B of the angle of ABC. Basically, what that means is sine using you're familiar with that. So sine is opposite over hypotenuse. Right, that's just Pythagoras theorem. Adjacent over cos is adjacent over hypotenuse. Okay, and so this is just a refresher for you. So, and that is how you find the other sides. All right, I think that is clear enough. Let's go to the next slide. We have discussed that before. So these are special angles now. These are the trigonometric functions of special angles. Special angles, we mean 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, and so on. We have picked 0 to 60 degrees. If you have sine of 0 will be 0, cos of 0 will be 1, and usually we say these are reciprocal of each other, cos and sine. Then tan will be 0 because you have tan will be sine over cos, 0 over 1 is 0. And cot is undefined, sec is 1, and cosec is undefined. The same thing when you use the Pythagoras theorem, the sides of this angle, you see 1 over 2. A side for sine will be 1, the other side is 2. That's what half means. Because I realized some of you did not understand that in one of the questions in the assignment. When I say 1 over 2, okay, what 1 over 2 means is, let's say sine now is right? That's so that's opposite over hypotenuse, okay? So it means 1 is equivalent to opposite. I'm talking about sine now. Okay, opposite. And 2 is equivalent to hypotenuse. All right. So that is what it means when you see half. When you say sine 30, sine 30 is equal to, sorry about this, it's equal to half, means this. All right. So it means 2 of the sides have been given. You know 2 of the sides. You know the opposite. Can everyone hear me, or is it just Wabisa that can't hear me? I need more people to tell me if you can hear me or not, please. Okay. Wabisa, I think something is wrong with maybe your laptop or your phone or whatever device you're using for the class. Every other person can hear me. Wabisa, please check your device and see what is wrong. Everyone can hear me. Okay. So this is what it means by half. And going to cosine, that means the side of the triangle is √3 and the second side is 2. Then you can easily find the third side. So that is actually why we have this. And if you're given the size, you just need to find the angle. If you know, let's say, for example, you don't know what theta is, and you have the opposite and hypotenuse to be given as 1 and 2, then you can easily use this table of special angles to know that your angle theta will be equals to 30 degrees. That is actually the usefulness of this table. Okay. Now this is where we should start today's class. Selecting the function in problem solving. We usually would have known angle and a known side. And in some cases, we have both knowns, we have known sides, and we would be told to look for the angle. Okay. But in any case, when you have a known angle and a known side, it's important that you choose the unknown side such that it falls in the numerator of the trigonometric ratio. You know, we have been using trigonometric ratio like so, ka, twa, okay? And then if you have a side, you'll see it in this example, that is unknown. When you want to choose a trigonometric ratio to use, it's always easier. You might do it in your own way, but it's easier to choose the unknown side, choose a trigonometric ratio that would have the unknown side fall at the numerator. Okay, so that is actually an easier way to choose and solve for the unknown side. Let's look at this example now. We have a wire is anchored 12 meters. Of course, we know where this is the pole, and a wire is anchored 12 meters up from the base of a flat pole, and the wire makes a 15-degree angle with the ground. Please take note. It's very important when you giving information such as it makes a 15-degree angle with the ground. That means the angle that this wire X makes with the ground is 15 degrees. Okay, that's if you miss that information, you may be having your solution wrong. You will actually have your solution wrong, because remember, you are going to be using trigonometric ratio to solve the problem. And I observed some of you made that mistake in your assignment. So please, read your questions properly and pay attention to every information provided. Okay, so here the question is, how long is the wire? So the wire is basically X, and which for us depends on, now let's use this our rule, this one here. We know this length to be 12 meters. This is what we're looking for, X, okay? We have given the angle. So we can, if we want this to fall, X to fall in the numerator, so we're just going to use sine, which I have, sorry, that's the denominator. So we can use cosec, right? However, if you're not comfortable with using cosec, you can actually look at it and say, okay, opposites over hypotenuse, then you use sine, because most of us are comfortable using sine. So that would be sine 15, which we have here already, equal to 12 over x. All right, very easy and straightforward. Just pay attention to the information given and work with your trigonometric ratio. And with this now, you can solve for x easily. And a lot of you did that well. I'm happy about it. Then we go to the next slide. So we also need to consider angles of depression and elevation. Angle of depression, when you stand at the top of, let's say, Table Mountain, and you look down from Table Mountain, from the top, what angle would that be? I need response. What angle is that? When you're at the top of Table Mountain and you're looking down. Yeah, it's angle of depression, because your head goes down and then you have a line, you make a line and then you look down, then the angle that you form is actually the angle of depression. So that's actually what I'm trying to explain here. And then when you look up Table Mountain, what you're having is angle of elevation. Your neck looks up and makes an angle. Makes an angle to the ground. That's angle of elevation. So all of those details will be used in practical sense. Remember, we are engineers and we need to pay attention to details. Since the line of sight AB is transversal, and that is intersects both parallel horizontal lines that forms both angles, then we have alpha, which is the angle of depression, to be equal to angle of elevation beta. Do we all agree to this? That alpha equals to beta. Okay, so we're going to apply that. And did I give you questions regarding angle of depression and elevation? I'm not sure. I can't remember now, but I'll see. So let's consider this other example. If the angle of elevation of a building's top changes from 20 degrees to 40 degrees, let's say you're standing here initially, don't mind me, let's say you're standing here and you look up Table Mountain, which is B, that's the peak, and you make angle of elevation 20 degrees, okay, to the top. And then that's when you are 75 meters away, or inch, or wherever. 75 meters actually should be meters, sorry. 75 meters away from the bottom of the mountain or the building. Now, you have moved, oh no, not 75 meters away. you, as the observer moves, sorry, you moving 75 meters to the base, the angle of elevation changes to 40 degrees, okay? Remember, we don't know what this is. You've only moved 75 meters towards the base, so we only know 75 meters. We don't know what this distance is. Now we're told to calculate the height of the building or find the height of Table Mountain. That is an example to actually pay attention to, because now I'm not sure if I should solve it. I want to draw that. Let me draw this here. It's just a rough sketch. Sorry about this. So just to remind ourselves, we're looking for this part. Okay. All right. Just to remind ourselves of that triangle. Now, this is A. Or can you guys remember? Just let me do this. It's gonna mess up the whole thing. Okay. Considering that triangle, okay, at triangle ABC, I'll flip front and back. This is ABC. We're given angle A to be 20 degrees. We want to find, this is where we're looking for this part. Let's call it X, this part. This is the question, height of the building. Okay, so we have angle AB to be 20 degrees. We have AD, line AD or side AD to be 75. Line AC is going to be what? 75 plus AD, right? Okay. And what trigonometric ratio are we going to use in this case? Can someone tell me? We are considering the big triangle ABC. So we have angle 20, we know that. What trigonometric ratio would you use to solve for X? Thank you. We use tan. Tan because we have opposites, which is X, will be divided by adjacent, which is what? So let me write it here. Tan 20 will be equal to opposite X divided by adjacent 75 so 75 is for no 75 is AD plus we'll add yes. Okay, you're using X, but I will represent that as maybe Y. Okay, so this part I'm saying is Y. So we have AC is equal to AD plus DC, which is 75 plus Y, okay? And now we can just express it to say X equals to 75 plus Y times 20, right? Yes, you're correct. AC plus DC. So, and that's how I've represented it here. So we have represented this as our first equation. What we have done is here. This is what we have done just now. Okay. Now let's look again at triangle DBC. I'll just flip back again. DBC. All right. So we have for DBC or BDC because the angle is actually at D, so it's better I said BDC. So what again are we going to use? We're still going to use the same tan, right? We have tan 40 to be equal to opposite x over y. That is BC over DC. And by the time you take for x will be y tan 40. Are you following? I hope everyone is following. I'm going front and back so you can see the picture, and then I'll go to the solution so you can see the solution. So we have for angle BDC, which is the second one now, it's this. Okay. So here we have two equations. The first equation for triangle ABC and the second equation for triangle DBC. All right. Now let's substitute equation 1 in equation 2. And that's what I have done here. Substituting please do try to follow and probably solve this in your notes so you're sure the answer is correct. Have you guys substituted equation 1 into equation 2? That's what I've done here. Okay. Do we all have our answer for DC to be 57.46? Do we all have the same answer, please? What answer do you have for DC? Okay. 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 So we have two people getting 57.445, which is also about the same thing as 57.5. Okay. Now, we're going to substitute DC now into equation 2. So substitute 57.5 into equation 2. So you will be having 57.5 tan 40. And I expect everyone to have 48.21 meters. Okay. So now we have our value for DC, which is 57.46, and we have for BC to be 48.21 meters. Now let's go back to the diagram. We have these two values now. We have DC, this Y is equal to 57.46, and we have been able to compute BC, which is the height of the building, as 48.21. I hope everyone is clear with this and we can proceed. Okay. So we want to look at the engineering applications of all of the angles, triangles, and all other unique angles. I mean, triangles we have considered. The first would be to look at vectors, and I'm sure a lot of us will be familiar with vector. What do you understand by vector? How is a vector different from just a line? Can someone tell me what's the difference between a vector and a line? Or can you tell me what you understand by a vector? Yes, thank you, Milos. Vector, a vector has both direction and magnitude. And that's actually the property of a vector that we will be considering. We'll take an example here. Yeah, Langutan, you said it has an arrow, but what does the arrow signify? That's Bradley now. I want Bradley to tell me, what does the arrow signify? Yeah, okay. Oh, thank you. It's the direction. Yeah, so that's a vector. We all know what a vector is. So let's go straight to this example because we want to apply what we have studied about angles and triangles and unique triangles and all of that. Let's look at the example where we're having a boat traveling at 12 miles per hour and it's traveling in a still water. And the boat is heading straight across the river with a current of 4 miles per hour. Before I go to the solution, I want to point your attention to this. The river has a current of 4 miles per hour, and the boat is traveling at this per hour. So tell me, what would be the effect of the current on the boat, on the speed of the boat? Can someone tell me what do you think will be the effect of the current on that boat? Okay, it may actually deviate the direction of the boat, but there's a unique effect. There's actually something that the current may want to do on the boat. Yes, it may cause friction, and when there's friction, what happens to the speed of the boat? Yes, it reduces the speed of the boat. Thank you. So that's actually when you want to apply all of this we have learned to vectors and in engineering and maybe to the speed of a plane, throwing an object up, putting an object on a slide, and all of that. We consider so many things because before you have an object moving, there would be equal and opposite force. You all know that. And sometimes you have gravitational force, sometimes you have the currents of a sea. You have different opposing forces that needs to be considered. And in some cases, you will be told that you need to ignore, for instance, you can be told to ignore the frictional force on that object. You